Right now we are testing the next phase of our rocket stove control system. Here's the rocket stove. There's the induced draft fan. We're blowing cold air into the exhaust to induce a draft to the rocket stove. We've added a new feature to it now. We've made ourselves our own turbine flowmeter for measuring airflow into the stove. This is a muffin fan, shamelessly stolen from some piece of electronic gear. It's an AC motor, and there's enough residual magnetism in the rotor that when it spins, it makes a very small, measurable AC signal. We send that AC signal through a shielded cable over here to an op-amp circuit we placed inside this thermocouple enclosure. And what that does at that point is sends out a high-level signal, on-off 24 volts DC, to one of the inputs on our PLC. So if we took a look at the I/O status right there, you can see the first bit on the I/O of the small PLC blinking on-off, on-off. And that corresponds to the peaks of the sine wave coming out of this motor. So the more air is drawn through the stove, the faster this will spin, and the higher the frequency will be of that signal. Our next step is to take the PLC and program into it a timer and counter routine where it counts how many pulses per second, and based on that it's going to determine a flow rate of air into the rocket stove. Our first phase of using this flow meter is going to be doing PID control based on flow, so we can establish a flow set point and then have the PLC control the speed of the motor to get the flow that we want to the rocket stove for precise flow. The next phase after that, we're going to be adding cascade control. We will have a master PID algorithm in the PLC looking at temperature of the rocket stove. The output of that master controller is going to go to the set point of the slave controller, namely the airflow. So we'll have a cascade system, temperature cascading to airflow. And that'll be the next phase of development on our system. Again, the goal of this is to see if we can precisely control the temperature of a rocket stove and throttle it up and throttle it down and check for efficiency and perhaps even emissions output from this project. One addition we got recently, we had a donation of an oxygen transmitter, a small oxygen transmitter, and I'd like to see if we can apply that to measure oxygen in the stack and see what the O2 content of the combustion might be. So we've got all kinds of potential here for our rocket stove project, but again, the big point, what we're doing here, the thrust or the emphasis in this program is we're learning how to do control. So regardless of what the process is, that's our purpose of doing this, how to use a PLC to do PID loop control on a process.